How's it going, everybody? So this might look like a bit of a mess, and it is, but it does have a purpose. So what we have here is a test rig for lithium polymer batteries. And in doing so, we're going to use these particle argons to verify that our system is turned on, which we have a lead wire coming from right here. So this goes directly to our switch. We have that guy running into the argon. So this is actually coming off our power source. We're running an auxiliary 12-volt battery right now. We're just doing the initial mock-up of the test itself. So since we're using 12-volt source power for the solenoids over here, we're going to have to run it through a voltage divider. So you can kind of see the little resistors in there. We're using a 3000 ohm and a 1000 ohm resistor. So that's going to cut it down by a fourth. And we have that pinned into the D0 pin, or on this guy it's the SDA pin. Oh, there it is. Sorry about my wonderful camera skills. So yes, we have that. We have a system voltage as well. So this red wire is connected to this solenoid here. So if the system wasn't connected to the auxiliary 12-volt battery, we would have this connected to the lithium polymers, and that's actually what power would be going through that solenoid itself. Now we only have 4 bulbs hooked up for this test. So with the breaker, master breaker on, and this guy engaged, bang, there we go. We actually have it turning on here. So this is actually drawing power. The particle would be pulling and measuring the voltage through there, and we have it actually calibrated to give us the proper readouts for that. And the last thing we have is we have a current sensor. So the current sensor we're using is an Allegro sensor. It's a 8772. It's rated for 200 amps, but we're only going to run it to 90 because that way we don't have to run a voltage divider on our board and do any additional calculations for the test. And I've done a bench test and calibrated the system using a external amp clamp here. So the sensor is supposed to be linear. There is a voltage offset for it. We calculated the voltage offset. The sensor is really good, and it's only by about plus or minus 2% difference for what we're seeing for current. So that's really nice. So we'll go back to the voltage here because I definitely skipped over that. So we have the Wheatstone bridge, or the voltage divider, excuse my misinformation there. We have that running. We have a bridged ground up here. So just so you guys know, all of the grounds on this guy are going to be bridged. So this is all connected to the auxiliary battery, which would in fact be the 12-volt battery in this case, but the lithium polymers for the others. And the only one that doesn't actually need it would be the switched power over here. Let's see what else. The pins going in for the voltage, you have your ground pin as a reference, and then we are pinning into a 0, which is going to be your first analog pin on the current sensor. I don't currently have it plugged in, but it will be going to the A0 pin as well. And then we have a 5-volt reference coming from the USB power. Is actually going to turn on that Hall effect sensor that we're using. So yeah, that's kind of the breakdown of what we have for this, and we'll have another video explaining the rest.
All right, thank you, Ian, for sharing that last part. So now we're going to go ahead and look at the argons. So the first one in the chain of command is the switch argon. So as you can see, there's no blinking LED light at the top of the switch argon. So if we go over here to the switchboard, we can follow where the sensor, which is the switch in this case, is connected. And if we turn that on, we see the lights come on. And then now we do see a blinking LED on pin D7 for the switch. So this is indicating that it's sending messages to ThingSpeak, okay, the switch is on. So looking forward to the volts, we can see that it is getting volt measurements because this LED light up here on pin D7 is blinking intermittently according to the code. So we've got it blinking for 2 seconds, off for 1, blink for 2 seconds again. And then once it reaches the end of the code, it actually is off for 5 seconds, and then it runs through again and sends the new voltage values. So the current sensor actually works in a very similar way to the voltage sensor. It's going to be on for 2 seconds, off for 1, and then at the end of the cycle of the code, it's going to be off for 5 seconds.